cross your hand.
What if you could fall straight through the Earth? One wild leap, a tunnel from New York to the Indian Ocean, no stops, no turning back. This isn't just a cartoon fantasy, it's a mind-bending physics experiment. Gravity grabs you, pressure builds, and the Earth's layers flash by in a blur. Suit up in our imaginary unobtainium gear. Ready? Let's dive. Science style. The adventure begins now. Taking a leap of faith, you jump into the tunnel. There's no turning back now. This is it, the start of an incredible, if slightly insane journey. The air rushes past you as you commit to the fall, a point of no return. Instantly, gravity yanks you downward, a powerful invisible hand guiding your descent. The feeling is immediate and intense, a constant reminder of the force that governs this journey. Accelerating at a relentless 9.8 meters per second squared. Each passing second brings a surge of speed, a constant climb on the velocity meter. In mere seconds, you're moving faster than a race car, blurring past any earthly comparison. The sheer velocity is mind-boggling, a testament to the raw power of gravity, the wind howling, or rather what would be howling, if there were air to carry the sound. But for the sake of this experiment and to eliminate pesky things like air resistance, the tunnel's been evacuated, creating a perfect vacuum. No air, no friction to slow you down, no terminal velocity to limit your speed, just pure, unadulterated, relentless acceleration. A freefall in its truest, most extreme form. You rocket through the Earth's crust, then plunge into the mantle, a dizzying blur of geological history flashing past in a chaotic high-speed montage. The faint surface light begins to fade, gradually replaced by an all-encompassing darkness, and the increasingly intense sensation of endless accelerating falling. After what feels like an eternity, but is probably only 20 minutes, you're essentially a human bullet, traveling at speeds exceeding thousands of miles per hour. A truly unbelievable velocity. The sheer scale of the planet becomes strikingly real as you plunge deeper and deeper into its core, the entire journey a bizarre mix of thrilling adventure and utterly surreal experience. You're venturing into the unknown, a place where no human has ever been, falling through the very heart of the Earth. The only constant companion on this incredible journey, the unwavering, unstoppable pull of gravity. You plunge deeper, heat and pressure skyrocket. Your suit strains as the world outside turns alien, the rules of the surface left far behind. Temperatures soar beyond anything on the surface, hotter than lava, hotter than the sun. The tunnel walls glow, rock warps and melts, and the air would vaporize anything unprotected. Pressure crushes from all sides, millions of times what you feel at sea level. Only our imaginary suit keeps you from being flattened in an instant. Suddenly, you burst into the outer core, a swirling ocean of molten iron and nickel. Here, Earth's magnetic field is born, energy and fire in constant motion. At the center, a solid ball of iron and nickel, Earth's inner core, suspended in the heart of the planet, squeezed solid by unimaginable force. You're falling through the planet's engine room, surrounded by extremes no human could survive. Only our fantasy suit keeps you intact as you approach the very heart of the world. But the journey isn't over, the unknown awaits, deeper and stranger than ever before. Gravity's grip changes as you fall. At first, all of Earth's mass pulls you down, but as you descend, some of that mass is now above you, pulling you back up. The deeper you go, the weaker gravity's net pull becomes. Your acceleration slows, even as your speed keeps climbing. By the time you reach the outer core, you're at maximum velocity. After that, gravity starts to slow you down. The mass above you acts like a brake. The journey is a perfect demonstration of Newton's laws. Acceleration, then deceleration, all dictated by your position inside the planet. It's a cosmic tug-of-war, and you're right in the middle. After about 21 minutes, you reach the exact center of the Earth. Here, gravity cancels out. Every direction pulls equally, leaving you weightless for a fleeting instant. But you don't stop. You're moving at peak speed, blasting through the center in a blink. It's a surreal moment, perfect balance, surrounded by the planet's mass, yet utterly free from its pull. Then, just as quickly, gravity's direction flips. Now, the mass behind you pulls you back, slowing your momentum. The sensation of falling vanishes, replaced by a new force dragging you toward the center you just left. The second half of your journey begins, slowing down as you climb toward the other side. The calm at the core is over. The braking phase has begun. Shooting past the center, gravity now works against you, pulling you back as you ascend. Your speed drops, the deceleration mirroring your initial acceleration. Through the inner core, outer core, and mantle, You slow at the same rate you sped up. In a perfect, frictionless world, you'd reach the surface on the other side in about 42 minutes, faster than a flight from New York to London. You'd pop out in the Indian Ocean, coming to a perfect stop, then immediately fall back in, starting the journey again. It's a flawless energy exchange. Gravity gives, then takes back every bit of your motion. But in reality, even a hint of friction would sap your energy, making each swing shorter. Eventually, you'd settle at the center, weightless and still. In our perfect scenario, you'd oscillate through the Earth forever, back and forth in perpetual motion, a human pendulum, swinging eternally. But real-world friction, unfortunately, would slow you down considerably, each trip shorter than the last, diminishing your momentum. Eventually, you'd come to rest at the core, suspended in the center, floating in eternal zero-G. This thought experiment reveals the hidden forces constantly shaping our planet, gravity, pressure, and the dynamic layers beneath our feet. It's a powerful way to visualize the unseen, the forces at play, and a reminder of the awesome science beneath us. While we'll never take this trip, in reality, imagining it teaches us about physics, geology, and the wonders of our world. The ground we stand on is more extraordinary and complex than we ever imagined.